So now we just have two branches, right? So Q1, Q3. We have two machines that are active, two branches operating, time going this way. Alright, now the fourth symbol comes in, is red. It's a 1, so 0, 1, 0, 1, 1, 0. Okay, so the fourth one, a 1 comes in. And now you have fingers. Oh, by the way, the finger that was on Q3, you take it off for that one, but it's still marked. Q3 is still marked, or fingered, or pinned, because of this one. But now Q2 is not fingered, right? Because Q2 transitioned to Q3, and nothing went into, nothing created Q2. So now at this stage you have two of the states with two machines. So this one's fingered and this one's fingered. The other two are not. Okay. I hope you're following me so far, right? With all these details. All right. Now let's see. Okay. So we have two of the machines, two states fingered. This one's fingered and that one's fingered. And as usual, you process each one sequentially. Step by step. So we'll process Q1, generate its offsprings in a sense, and then we'll process Q3 because they're the two that are fingered or pinned or indicated somehow. All right. So let's do Q1. So we're back here again. Well, again, we'll have it. So here and here are the same, right? So what we got here, we'll get again here. Right? It's just repeated. So Q1, it can loop back to itself, because the symbol it's read is a 1. Okay, here. So the fourth symbol is a 1. So it can go back to itself. So Q1, so that would be that transition. It can go to Q2, so that would be that transition. And every time you go to a new state, check for the next. If the next connection includes an eta. Well, it does. Okay, so that means you put in a Q3, the state that this eta is pointing to, that transitions to. So you put it in a Q3. Okay, so now you've got where you had one machine here, you've now got 3. So you've got your 3 copies of that machine, but they're in 3 different states. So this one didn't change. The state didn't change. So that machine, that copy, will be in state Q1. The machine, if you take that branch, then you're in state Q2. That's that one. And because of the eta, you look at the next state, the one that eta is pointing to, and you create another copy of the machine and put its current state into that state. So you go Q3. Okay. Now Q3. So we've analysed Q1, the one was pinned. Now Q2 is not pinned, forget about it. Q3 is pinned, so what happens to Q3? What's the input? Well, the input symbol is 1. Now that is marked, and there's only one 1. Okay, so deterministically, Q3 goes to Q4. Right? That's there, right? So now you now have 4 machines, all running independently in your processing. 4 machines, right? 1, 2, 3, 4, and all 4 states. Interestingly, so you've got your fingers on. You've got a finger on each state, or you've pinned all 4 states. Okay, all right. The next step, a 1 comes in. So and you analyze each one in turn, right? So let's get Q1. Now, so we're here, and again a 1 comes in. So again, this splits 3 ways, just like this, just like that. Okay, so the same reasoning. So I won't go into detail because I talked about it twice already. It's the 3rd time. Okay, now Q2 reading a 1. What happens there? Q2 reading a 1. There's no 1. There's no exit transition arrow with a label 1 on it. Therefore, Q2, when reading a 1, dies. Right? It just dies. So this branch terminates. It dies. There's nothing. It has no successor. So that dies. All right. Q3. What does it do? It's reading a 1, so it deterministically goes to Q4. Okay. And Q4, reading a 1, just loops back to Q4. So now we have 5 machines. But these two are the same. So now, what do you do now? Well, there's not, if you think about it, there's not much point finding out what this thing does, because it'll just be a repeat of what this thing's doing. Okay, just wasted effort. It's pointless. Because remember that what's the point of an NFA? How does it process? What's it doing? It's trying to, if just at least one branch ends up in a final state that belongs to one of the accept states, then the whole NFA is said to accept that string, that input string. Okay, so given that sort of a main task, there's no point just copying it. So in effect, you can just forget about this branch, right? Because it's just a copy. So in general, if you look along a particular step, and if you see any copies, like any two states are the same, you can eliminate one. I mean, it'll still effectively still processing away, but you don't have to bother with it because you've already analysed that state the first time. So when you see a second state, a second machine in the same state as some machine in the same state that you've previously analysed in the same time step, don't worry about it. Just forget it, because it's just repeated work, right? Just extra work, pointless. Okay, so let's say you figured out this one. Okay, so now effectively we've got 4 machines. I mean, we really have 5, but don't bother about the repeats. So again, we've got four machines in all 4 states. So all 4 of them are marked. Alright, so now the last symbol comes in, the sixth symbol. Okay. So let's see. And it's 0. Okay, it's a 0. The 6th symbol to come in is 0. So and we look at each 4 machines in these 4 different states, one at a time, because they're all functioning away independently. So what will Q1 do reading a 0? Q1 reading a 0 goes back to Q1 deterministically. Right? There's only one arrow labelled 0. So it deterministically goes to Q1. And what does Q2 do under 0? Well, it goes to Q3 deterministically. Okay, so it goes to Q3. Now what does Q3 do reading a 0? Well, there's no 0 on an arrow coming out, so that dies. That branch dies. So that just dies. Okay, there's nothing here. It just dies. And Q4, what does it do reading a 0? It's already in Q4. It reads a 0, just comes back to itself. So it's there. Now we forgot about it because it's just the same, right? Just be the same. Okay, so that's now our final stage. And you have a look at all these various branches. Now there'll be 4 branches. Well, effectively 3 because of the repeat. And you have it now. Are any of those final states belonging to the set of accepted states? Because Q4 is the accept state. Yes, there is one. Let's see. This branch, that branch, that path, if you like, that led to an accept state. Therefore, this whole automaton, this NFA, non-deterministic finite automaton, it accepts the string 010110. Okay? Alright. Now that's quite a bit of detail. That's quite a long quite a long session with all these details. In fact, I think I've gone through most of this. You can read this up, but I've said it all pretty much. This is what I've just been saying. Okay. All right. Okay, so this NFA, non-deterministic finite autotonic N1, it accepts the string 010110. Okay. Now, what about string 010? Well, psychologically, you're probably guessing that it will reject it. And that's the case, but explaining why that is the topic of, well, topic of the next session. So I'll stop there. This has been a rather long session.